Good afternoon, Assalamu alaikum. Welcome everyone. Thanks for joining. So on this session, we will talk about Kubernetes security. My name is Jasim. I'm working in Astha IT as a DevOps engineer. This is my LinkedIn ID. This is my email ID. Feel free to connect with me. I'm always uh, feel good to meet with new people. So in next 20 to 30 minutes, we will talk about what are the state of Kubernetes in the real world scenario, why we are facing so many challenges in Kubernetes security, and the threat matrix. We'll go through a case study. We'll specifically look through the attack chains, which makes Kubernetes vulnerable, and some mitigation techniques and conclusion. So that's it. So, as a myself, I feel very comfortable communicated with number. I don't know this is very visible or not. Basically, this left chart is showing that from 2018 to 2023, there is 440x% increase of Kubernetes vulnerabilities. And uh, if we consider only last 2023, among 60 plus vulnerability are come from Kubernetes ecosystem, and 7 are from Kubernetes itself. So these are the number I just giving you to correlate the next discussion topics. So if we go to the CBSS score, you can see that the point I have highlighted, majority are either high or critical. So that means these are highly exploitable. This is a survey done by Red Hat. So they publish, every year they publish State of Kubernetes Security Report. As you can see, among the participants who joined the survey, most of the guys facing project delay, customer loss, revenue loss, fine, even job termination due to Kubernetes security. And more than 90% had give feedback that they are, in last 12 months, they faced at least one critical Kubernetes vulnerability. So again, I am giving this picture to make the correlate the next topic. So this is a survey done by Wiz Research. What they did, they put a honeypot and they see how Kubernetes survive in the wild. So what they see in the top 3 cloud provider, it took maximum 3 hours to have after spinning up a new instance of Kubernetes, it took maximum 3 hours to have a hit, malicious hit. And sorry. Okay. 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 Okay, thank you. So next is, if we analyze the vulnerabilities of the Kubernetes, we see that more than 40% are having high vulnerabilities. So this is something I truly believe myself, and I want to share with you. Just take it in. It basically says that you cannot secure anything if you don't understand it properly. And more you know about it, better you can secure about it. So as a layman, outsider who are new in the Kubernetes world, they might ask, it is basically a software. Why it is so hard to secure a Kubernetes system? What is the funda here? The main challenge is, if we take back 1 or 2 footsteps, we can see the Kubernetes itself trying to solve many things, from high availability to storage to multi-node clustering. Lots of things Kubernetes trying to solve. To solve this kind of so many things, its architecture become inherently complex. So there is lots of API calls between the components. And when you try to secure them, you have to consider the every layer and put security boundary there. We will, in the later discussion, we will talk about that. Kubernetes rapidly evolving in every new, almost every year, uh, twice they give a new version. And in every new version, there is new vulnerability gets surfaced. And since it's dynamic and distribution nature, multi-tenancy challenges, this problem doesn't get solved. These things get more complicated. One of the core issue that security guys complain about Kubernetes that regarding its configuration and the default security loopholes, and also the integration with the existing system. Basically when you run a Kubernetes, you cannot run it as a standalone. You have to integrate with your existing ecosystem, IT system, and then you have to secure the both, the IT system also and also the cloud native part. This is particularly important skill gap. Lots of guys, we are knowing the Kubernetes, we are embracing the Kubernetes, we are deploying in production. But there is a very significant gap in terms of Kubernetes security in the market. And this is worldwide. This is not in Bangladesh or in local community. And as I have seen in the last slide, there is, when you publicly expose a Kubernetes endpoint, it will get attacked. And the number of vulnerabilities, it is very high. So people might ask, what is the impact? This is the impact. This is a screenshot of 2018 news. Tesla, everyone knows Tesla. This is a giant. So their Amazon account got hacked. And through a bug bounty program, they came to know that their resources has been used for cryptocurrency. So how did it happen? It basically happened via Kubernetes dashboard. In previous version, Kubernetes dashboard was exposed by default. So in latest version, it is by default. You have to manually enable it. But in the previous version, it was exposed. So when you expose those endpoints, basically hacker can make a graphical diagram of your setup and do lateral movement, privilege escalation, those kind of attack. So I am saying about default. Normally we have seen in the default setup, software companies or software setup give best practices in the default setup. But in Kubernetes, that is not. Kubernetes basically built for private, very secure data center. Kubernetes was built around the Google Borg. So that was in a very complex and secure environment. But what we are doing, we are moving everything from traditional VM to Kubernetes, and then we are exposing it publicly. So that layer becoming exposed. I talked about dashboard. Dashboard is, in latest version, is not publicly by default not get allowed, but when security researcher has surveyed worldwide, they found that majority of the Kubernetes setup are running older version. So you might ask why they are running in older version. So that is, if you correlate that, when you running in Kubernetes, how many times you have upgraded your setup? Very few, because once your production workload is running, you are afraid to upgrade the version. And those security loopholes stays there. The Kubernetes API server by default only allow basic authentication. And their RBAC policy is too permissive. So you can do all sorts of privilege escalation attack on that. And the HCD doesn't have any client certificate or REST encryption. So it is if someone try to do collateral attack, they can easily attack HCD. and there is no PSP, no network policy by default, and the secret password, and you are know the secret keys, those are encrypted at base 64, and base 64 are again stored in etcd as a plain text. So anyone have access, they can easily decrypt this. Finally, Kubernetes by default doesn't come with any comprehensive logging or monitoring system. So very few basic logging is there. You have to integrate third-party tools to have that full suite of logging and monitoring. So these are the lots of people running Kubernetes with this default setting. And then the attack surface gets longer. This is called threat matrix. If you are not familiar with security threat matrix is basically all the possible endpoint why by that attack surface hacker can attack you. That is done by reverse engineering any software. So I'm not going to explain every bit of that. I'm trying to give a keyword to you. So when you go home, you can search in Google, because if you go to the site, the first site will come in the Google, you can, this, only to explain this site, we will require a full day session. So this is not the right place to explain this. I'm just giving you the metric, keyword threat matrix, Kubernetes threat matrix. If you are trying to secure your production deployment, just follow their guideline. This was originally developed by Microsoft. Later, all the, including Red Hat, Google, XYZ, everyone adopted this matrix. So here I am trying to give you a case study, real world case study, how a Kubernetes attack happened. I think the color get lost here. So it is very hard to see here. So basically what happened here, I will wrap up this case study part within a 30 seconds. So what happened here, that there was a publicly exposed endpoint in EKS, Amazon. So what happened, and there is a known vulnerability there. So what they did, they attacked the container, and through container, they privilege escalated to the VM. And when they got the VM level access, those IAM was too permissive. So they got to attack the confidential data, and later they erase their backtrace. And basically they keep to mind the full setup. So this was by James Security. This was a real world example how a Kubernetes attack tree work. So there are lots of scenarios like this. This is a basically summary, because there is all possible way of combination how a Kubernetes attack can be done. But here, this is a survey of more than 200 type of attack. And this is the summary here. I try to put it here. Here in either through control plane or data plane, Kubernetes hacker get access, and then they do multiple lateral movement or privilege escalation attack. And finally, the impact is the result, what they are getting. Either DOS, secret, image poisoning, then or privilege escalated to cloud. So if you want to find out how all these attack, other than reading every single attack case, I think this is a good summary. Here you will get a summary how attacks are having, attack chain work. So we know the problem, how we can solve it, what we can do about it. We know this is a big problem, we understand, I think we have a good picture. It is a real world problem. But what can we do about it? So as I mentioned before, sorry. So any attack, for any countermeasure, you have to follow a proper framework. Without proper methodology, you cannot fight um, in long term, you cannot fight your enemy. So for this, framework is important. So if you go to cloud native security, the default standard is 4C. That means cloud, cluster, container, and code. You have to secure this 4 layer. This basically deprived from the original. Many of, if you know about security, you know about defense in depth. That basically layered approach. This is derived from physical military, like World War I, World War II. That's how they strategically minimize the attack of enemy. So what they did in the different layer, they fight with the enemy and weaken the enemy. So that is called defense and depth. And from defense and depth, this 4C derive. And on top, you can see the what is called zero trust. So I think most of you are known about zero trust. That basically says that you cannot trust anyone. You go with least privilege and go up from there, and you secure everything, and you centrally manage that. That is the basically philosophy. So here I try to list down major best practices for Kubernetes security. When you deploy a Kubernetes setup, these are the common best practices. You implement RBAC and you properly, not like default, you properly partition your namespace. You use third-party authenticator. You know, by default, Kubernetes AA, AAA is not very secure. You protect your etcd with TLS, firewall, and and encryption. You partition your network, you monitor everything, and enable audit logging. Another interesting feature is process whitelisting and admission controller. Lots of things are not normally enabled by default. And of course, for things like any software, you use latest version. Many of us try to secure only the etcd or API part, but we forgot the kubelet part. Kubelet one is in a study it is found that major vulnerability come from kubelet, because by kubelet you can actually attack the node itself. Finally, you have to secure your supply chain. So that means you have to establish a DevSecOps process from image to final code. I will go in depth in there also. So again, color is, because of color, this is not very visible. But what here showing from the first public code repository to third-party library to source code, compiling, Docker registry, container image, and container registry. These all are the attack vector for any setup. And you have to secure, when trying to secure it, you have to be careful on every part. So this is done by Snyk, a security firm. What they found that all the top popular Docker image, from Node to Nginx to Ubuntu, everyone has the bar chart is showing the vulnerability number from 580 to 30. So this is the minimum, all the popular Docker image with minimum 30 vulnerability. Finally, this is another place where I want to keep your attention. When you do zero trust security, how you can make the trust boundaries. So in terms of threat modeling, trust boundary means, if you see the radar means that these are the secure, trusted boundaries. When you move from one red area to another area, you have to secure it. You have to block it, you have to enable logging. And the green are the machine level separator. That means green, but showing here yellow. These are the machine level separator. These you have to physically separate via VM or physical machine. You have to separate this. By that, you will achieve high availability and required segregation. So in terms of mitigation, lots of people, when we come to DevSecOps, people tell you about lots of tools. But in my understanding, the first have to come the people knowledge, because there is lots of organization have lots of tools, but there is not enough resource is there who can actually operate those tools. So you have those training and certification, and also you must have those process. So that only can secure you. Finally, you have the tools. That is, Kubernetes security landscape is very rich. In every area, you will find multiple tools. And I will not go in the detail here. Time is very limited. Basically, if you go to the security CNCF landscape, in the security part, you will find these tools. So you can play around those. You can find your suitable one, and you can implement one. Finally, in conclusion, security is a never-ending journey. You cannot call it a day. You sleep at night, but hacker is not sleeping. So this will always be continuing. But through implementing the best practices, you can have a highly secure system, which is less exploitable. If there are any question you may take, I will take maximum one question, very short. If you have anyone, otherwise we will wrap it up. No question? Thank you. Thank you for everyone.